Okay, so we're on to our last section for Unit 1, and that's going to be 1.8, solving absolute value equations and inequalities. So what we're going to do here is we're going to review absolute value real quick, and then we're going to throw in um, inequalities with those. So what is an absolute value? An absolute value of a real number, n, is denoted by these little hash marks on each side right here. And absolute value is defined as the distance from 0 to that number on a number line. Distance is always a positive number. So whenever you take the absolute value, your solution is always going to be positive, unless you're taking the absolute value of 0, because then you would be 0 units away from 0. But in our example right here, we have the absolute value of -4, and that answer is going to be +4, because we're just asking you how far is your distance, how far is that number from being at 0? And so it would be 4 units away. Same thing as the absolute value of +4. It would still be 4 units away from 0. As we said, we're going to measure distance is always going to be positive. So let's perform the indicated operation. So this is pretty simple. It's basically the same thing I have up here. So if you were to picture 7 on the number line, it would be 7 units from 0. Same thing with -7. Oops, I almost just tripped up there. -7 would be 7 units away from 0. And then on C, the absolute value of 0 would be 0. So that's the only case that you get 0. Other than that, you'll always get a positive result. Okay, so we're going to look at solving equations involving absolute values, and then in a moment we'll throw in the inequality signs. So steps for solving an absolute value equation. Step 1, isolate the absolute value if necessary. So basically you want to get it into the absolute value is equal to some value A. Now if that value A is less than 0, if it's a negative number, automatically there is no solution. And we'll talk about that in a minute when we run into that. Otherwise, if A is greater than or equal to 0, so if it's 0 or a positive number, then you're going to rewrite the absolute value as x equals A or x equals -A. Then you're going to solve those. So typically, not always, but typically, you're going to get two solutions to these. So looking at example A right here, we have the absolute value of P equals 7. Well, 7 is a positive number, so I don't have to worry about the no solution. So then what I have to do is rewrite this absolute value in terms of P equals 7 or P equals -A, which in this case would be -7. And so those are my two answers. My two answers are 7 and -7. Either one would work. That's why we use the or. So 7 or -7, when I plug that in, when you take the absolute value, you get 7 for both of those. Those are both 7 units away from 0. Now, if you look at example B right here, we have a problem right away because we have the absolute value of x equals -7. Well, we already said that's going to be no solution. Well, why is that? Well, if you rewind the video about a minute or two ago, I just talked about how your results will always be positive numbers. There's only one case in which you'll get 0, and that's if you're taking the absolute value of 0. But other than that, you can't have negative distances. So right here, you're trying to find the a value's distance from 0, but by definition, distance is going to be looked at as a positive result. So this one's going to be no solution. Okay. And then here was our special case right here. So the absolute value of x equals 0. So if you put x equals 0 or x equals -0, 0 is really neutral. It's not actually positive or negative, so it's kind of silly to have that negative with it. So we really only have one solution here. It's just 0. So that's the case where you only have one solution. Okay, as we look at a couple of these others, they're going to get a little bit more complicated. So right here, we have the absolute value of y minus 3 equals 7. So what we're trying to do is figure out two different values for y, that when we plug it in and subtract 3, that distance will be 7 units from 0. So what we're going to do here is we'll take this expression y minus 3 and try to figure out what do I have to plug in to get 7, or what do I have to plug in to get negative 7? Because that would be 7 units from 0 also, right? Negative 7 is 7 units away from 0. So then we solve both of these. So on the first one, let's see, we add 3 and we get y equals 10. And then on the second one, we add 3 and we get y equals negative 4. And so those are our two solutions right here, 10 and negative 4. And so if I plug in 10, 10 minus 3 is 7. 7 is 7 units from 0. If I plug in negative 4, I'll get a negative 7, but the absolute value, that distance, is 7 units from 0. So either one of these creates a true statement here. Okay, so for the next one, kind of the same deal. So let's see, we're going to get 5 minus x equals 2, or 5 minus x equals negative 2. And so let's see, we got to subtract 5, and we actually have one extra little step here. We're going to have to get our x value positive, so we're going to divide both sides by negative 1. And so this first solution is x equals 3. And then over here, let's see what we're going to do. Let's subtract 5 again. So we get negative x equals negative 7. And then we'll divide by negative 1, causes a sign change. So we get x equals positive 7. And so those are my two solutions for this. 3 or 7 would work. 3 or 7 would work for example E. And so as we continue, the examples just get a little bit messier with the algebra, but really it's nothing we haven't done before. So let's go ahead and take this expression, 2x minus 3, and you set it equal to 14, or 2x minus 3 could equal negative 14. And then we go ahead and solve each one of these. So here we go. So my first one, I'm going to get x equals, and I would just keep it as a fraction, 17 over 2. And then for our other one, let's see, we're going to add 3, add 3. So we get 2x equals negative 11. We'll divide by 2 also here. And so we're going to get x equals negative 11 over 2. And so those are my two solutions. So if I plug in 17 over 2, that would create a true statement. Or if I plugged in negative 11 over 2, that would also create a true statement. Okay, looking at G, I have the absolute value of 3x plus 7. That distance needs to be negative 4 units from 0. That distance needs to be negative. Uh-oh. Distance, we don't measure distance in terms of being negative, so this one's going to be no solution. Oops, my dyslexia is kicking in. All right, there we go. Sometimes I get my numbers backward, but I guess my letters too. All right, let's see. Moving on. Let's see. So now we're going to throw in the absolute value. And so this can be a little tricky, okay? So I'm going to give you a rule here that if you follow the rule, you should be fine. You shouldn't get in any trouble with it. But if you're looking for a little deeper understanding, we'll kind of take a little deeper dive also. So let's see, what are we working with here? So if the absolute value of x is less than a, and a is greater than 0, so a needs to be a positive number, then what we'll do is you actually take that value, that absolute value, and you're going to squeeze it between negative a and positive a. So it has to be greater than the negative a and also less than positive a. And so why is that? Well, let's look at an example here. And so right here we have the absolute value of t is less than or equal to 3. And so what we're saying is t cannot go further than 3 units away from 0. So here's where 0 is. And so t, the absolute value, which means the distance from 0, so if you kind of put it in that terms, it might make a little bit more sense. So the distance, this variable's distance cannot be more than 3 units away. It has to be less than or equal to 3 units. So it's distance. So I can go to 1, 2, 3. I can't go beyond 3 because I have to be less than or equal to 3. My distance has to be less than or equal to 3 from 0. Same thing if I go in the other direction, -1, -2, and -3, and so on. So my distance, I can't go beyond that. So this is actually what the number line looks like here. It's going to be all these values between -3 and +3. And so if you follow the pattern up here, the pattern is you take that value here, and we're going to squeeze it. So it's going to be greater than or equal to -3, the opposite of this value, and then less than or equal to +3. And actually, I already have the graph here, so I'm not going to worry about graphing it again. And then my interval notation would be bracket -3 to +3. Okay, my next one right here says the absolute value of t, its distance, needs to be less than or equal to -3. So my distance has to be less than or equal to -3. Well, that's a problem, and if you look up here, I actually define it as a problem. If the absolute value of x is less than a and a is less than 0, which means it's a negative number, then the inequality does not have a solution. So basically, whatever you plug in here, remember, whatever you plug in is always going to come back positive or 0. So like the absolute value of 0 is 0. The absolute value of -5, the problem with that is that's going to come back as +5, so you're going to get a false statement. So no matter what value you plug in for t, it's always going to come back as a false statement. So this one's just going to be no solution. And when you're doing your homework, sometimes they'll use this abbreviation does not exist. So just kind of read your directions because they might use that in place of no solution. Okay, so like I said, if you kind of follow these rules where you squeeze it, you should kind of be okay. But if you kind of take a moment and just kind of think about what they're asking you, they're asking you, or they're telling you this distance needs to be less than or equal to 3 units. And so it's going to get a little bit more complicated on these down here. We're going to throw a little bit more algebra inside the absolute value right here. But basically, we're saying whatever this is, whatever you plug in for x, but once you subtract 1 from it and take the absolute value, its distance has to be less than or equal to 2 units from 0. So here's 0, right? Now, what complicates this is it's not like the last one where it's going to be between -2 and +2. That's what the last one was, right? Wasn't 2, it was 3, but it was getting squeezed between those the 3 and the 3 and the -3. But what's going to be different here is we have the x minus 1 in the middle, so we have a little bit more algebra we have to do. So if you follow the pattern that was given up there, what you have to do is take this and squeeze it. It's going to be less than or equal to 2, but it's also going to be greater than or equal to -2. Okay? So, and then from here we have to solve this, and you've done this in a previous lesson. So here we're going to just add 1 to both, or all 3 parts, I'm sorry, all 3 parts. And so let's see, this becomes -1 is less than or equal to x, which is then less than or equal to 3. And so my solution set is actually going to be squeezed between -1 and -3. So -1 and I'm sorry, and +3, not -3, +3. So there's my solution set, and then my interval notation is from -1 to +3. And if you want to, if you're still skeptical, you can plug in some values and see that they come back as true. So like if I plug in -1, this would become the absolute value of -2, which is 2. 2 is less than or equal to 2, which is a true statement. And so same thing, if I plugged in 0, if I plugged in 1, I plugged in 2, all those values would come back true. If I go beyond my brackets right there, then I would have a problem. So try not to overthink it. Like I said, if you just follow the formula, you're going to be all right. So this quantity right here, when you take the absolute value, has to be less than 8. So its distance has to be less than 8 from 0. So here's 0. I can't wander off in either direction more than 8 units. Now, yes, the 2x minus 8's I'm sorry, the 2x minus 6 kind of complicates things. So what I'm going to do is squeeze this. It's got to be less than 8, but greater than the opposite, negative 8. All right, so then from here, we'll go ahead and add 6 everywhere. And so let's see, we get negative 2 is less than 2x, which is then less than 14. And then we'll go ahead and divide everything by 2. So we're going to get negative 1 is less than x, which is then less than 7. And so that's what I have to squeeze this between. So negative 1 here and 7 here. It's kind of arbitrary. I'm just kind of drawing a little generic graph. And then last, we need to put the interval notation. So, and I'm using parentheses this time because of the inequality did not have the equals to part. So what I want you to notice about these examples is this was all the less than or equal to example. So we are looking at the absolute value being less than or equal to. So now we're going to actually look at what happens about the absolute value is greater than or equal to. So this is our last slide here. So if the absolute value of x is greater than a and a is greater than 0, okay, so that's one of our stipulations, then what we're going to do is you're going to look at what if x, look at all the values that make this statement true that x is greater than a or x is less than negative a. So it's what you're going to do is look at kind of like the statement that you kind of have if you were to drop the absolute value. If you were just to drop the hash marks, look at that. And then also look at the opposite and flip your sign. So flip the sign and then change the sign of whatever A is in this case. Now, this is kind of an interesting case here. We haven't seen this yet. If 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 the absolute value of x is greater than a and a is actually a negative number, if it's less than 0, then the inequality has all real numbers as its solution set. And so we'll look at an example of that in just a minute. So looking at this first one, what we're saying now, once again, if you kind of think about this, remember absolute value is distance. We're saying the distance of the set of numbers I'm looking for, that's x, my variable, the set of numbers I'm looking for, its distance needs to be greater than 6 units from 0. So here's 0, and the values I'm looking for need to be greater than 6. So for example, let's see, we got 1, 2, 3, 4, 5, 6, 7, and so on, right? Well, think about these values if you plug them in. So if I plugged in, let's say, for example, the absolute value of 2 is greater than 6. So I'm going to get 2 is greater than 6. Well, that's false. That doesn't make sense. So that doesn't work. So see, 2 doesn't work. If I plug in 6, it wouldn't work because 6 is not greater than 6. But if I plug in 7, that'd be great. Or if I plug in 6.111 or 001 or whatever, that value would work. So everything greater than 6 works. And so once again, if you're following the pattern up here, that's what you would write down. You'd say, okay, x is greater than 6. That's one of my solutions. So that would be all the values to the right of 6, right here from 6 to infinity. Or I take x and then I flip the sign and change the sign of my number. So this is going to be less than negative 6. Well, negative 6 is over here, and values less than negative 6 are like negative 7 and so on. And so now I'm going to shade over here towards negative infinity. So my solution set, you want to go from low to high when you do your interval notation. So it's going to be from negative infinity to negative 6 parentheses union from 6 to infinity right there. Okay, and so think we've discussed this symbol before, but yes, the union, it's just like, it looks like a capital U. It just means this set and this set right here. These two sets together. Okay, if you look at F, that's going to be our special case where the the A value is negative right here. So automatically it's going to be all real numbers. So let's look at Y. Well, plug in whatever you want and it's going to be true. You can take the absolute value of negative 100. Well, guess what? That's going to come back as positive 100, which is greater than greater than any negative number, but greater than negative 6. Anything you plug in is going to be greater than negative 6. Even if you plug in like negative 3, well, that's positive 3. All positive numbers are greater than negative numbers. So once again, that works. So you could stay here all day and come up with numbers and plug them in, and they are all going to work. So as far as your number line, the way that would basically look is you would just shade in both directions with arrows going, and there'd be no empty spots. And then for your interval notation, it would be from negative to positive infinity. Okay, so once again, if you follow our rule up here, you're going to be in pretty good shape. And so it's different from the other one. The other one, we were looking at the less than, and we kind of squeezed it. Instead, what we're doing here is you kind of look at what you got, and then you flip the inequality sign and change the sign of your value and solve both of those. And we're going to be shading outward. We're going to be shading outward. So you're going to see that pattern. Over here, the pattern was you were shading in the middle. You were squeezing them. All right, so let's go ahead and try these. So don't, when they get more complicated, we start to kind of overthink it. But if we just kind of follow the pattern that was established, you should be fine. So we have the distance needs to be greater than or equal to 4 units. This that I circled. This distance, x minus 1. X minus 1 needs to be greater than or equal to 4 units from 0. So then that actually works in the other direction. So x minus 1 needs to be less than or equal to negative 4. Now I'm covering the other side of the number line towards negative infinity. So now I'm covering both directions. So we're going to solve both of these. So on the first one, we'll add 1, and we end up getting x is greater than or equal to 5. And then on the other one, we're going to add 1 on both sides, and we get x is less than or equal to negative 3. So let's see, probably want to go in numerical order here. And then let's see, I'll put my 0 right there. And so what we're going to do here is x is greater than or equal to 5. So we're going to go here and shade. And then x is less than or equal to negative 3. So we're going to go here and shade. And so then my interval notation is from negative infinity to negative 3, union from 5 to infinity. All right, let's look at our last one here. And so let's see, we have the absolute value of 3x minus 8 is greater than 7. Our distance needs to be greater than 7 units from 0. So take that expression and make it greater than 7, or 3x minus 8 is less than negative 7. So once again, just follow those patterns and you're going to be okay. Like most things in math, as you do more of these, then you start to kind of understand why these rules work the way they do. Okay, so here we go. On this first one, we'll go ahead and add 8 to both sides. So we get 3x is greater than 15. And then we'll go ahead and divide by 3 on both sides, and we get x is greater than 5. And then over here, let's see, we're going to add 8 to both sides, and so we get 3x is less than 1. And then we'll divide by 3 on both sides, and so we'll get x needs to be less than 1/3. So once again, plot your values here in numerical order. So 1/3, we can put 5 here. And so this is saying x is greater than 5. So numbers greater than 5 go to the right, like 6, 7, and so on, towards infinity. And then this is saying x is less than 1/3. Well, values less than 1/3 are going to go to the left. Like, 0. 0 is less than 1/3, -1, and so on, going towards negative infinity. And then last, we just want to go ahead and convert this into interval notation. So this is going to be from negative infinity to 1/3 with the parentheses, union from 5 to positive infinity. Okay, that completes our Unit 1. Once again, if you have any questions or concerns, just make sure you reach out.